Okay, hello. Today we're going to be doing section 4.5, which is overriding a function rule. It's a fairly quick lesson, and hopefully once you see the video, you can then get a little practice. We do have a couple of questions here that are kind of a mixed review. And the first question, is this function linear? The second question asking the same thing. So what I'd like you to do is look at 1 and 2 for a second there and decide if that function is linear. I'll give you a second. I'm going to pause. Okay, so hopefully you took a minute or two to look at those problems. What I want you to think about is when it is a linear function, it has to go by a certain pattern. So what I like to do is look at that y value. So here I'm going to go across and see if I can see a pattern as I'm going down the y value there. If we look here, we have it -1, then we have no change at all. And then we have a -2, and then all of a sudden we're adding 1. This pattern does not indicate that it is a linear function. A linear function would be going by a repeated pattern up or down on the y without multiplying, so adding or subtracting. So in this case, it's not the same value, so that is not going to be a linear function. If we look at the second one here, again, looking just at the y values, we can see that it's going up by 1 each time. So it's that constant pattern that would be an indication that that function is linear. So yes, that one is going to be a linear function. And you can always check it by graphing. If you graph those points, we know that a linear function should be in a straight line. So that's another way to kind of check those patterns. Now, there's just a few references that I want you to be aware of here from your notes. So if you want to just use a highlighter, grab a highlighter real quick. In this first part here, these are key words to look for when you are writing a function rule from a verbal description. So words that would suggest addition, words that would imply subtraction, multiplication, and division. A lot of these you've heard of before. Some are used more than others. So just be aware this is a nice reference for you as you are translating from verbal expressions. So if we look here at this problem, they give us something verbally and they want us to write a function rule to represent that sentence. So right here it says twice a number n increased by 4 equals m. So we want to translate that into a function rule, into symbols. So we could rewrite that as 2n plus 4 equals m. So we can write functions to represent situations and then evaluate the function to determine a particular value. So again, here's an example. A sales associate earns $500 per week plus 4% of his sales. Write a function rule for the amount he makes in a week if he sells S dollars of merchandise. How much will he make if he sells $4,000 worth of merchandise? So the first thing we want to do here is write the function rule. So we're going to look at the important information here in the problem. So let's say E is going to calculate how much he will make. So E is your earnings, I guess. So he starts with 500 per week, plus he gets 4% of his sales. So notice whenever you have a percent, you always want to change that to a decimal. So 0.04s for his sales. Then we're going to use this function rule to calculate how much he will make. So if he sold $4,000 worth of merchandise, we can plug that in for S in the equation and see that he would make $700 then for those sales amounts. So here's just a quick example that's kind of already worked out for you, a chance for you to see how to organize your information. So we've got several problems here that we're just going to kind of practice with. Number one is just asking you to write a function rule. It is not asking you to solve for anything. So here it says, what is a function rule that represents the total amount of waste after m months? So they want you to use the variable m. So what we want to do is just look at that problem and look for those key words and just write a function rule. We don't have to actually solve it in this case. So a landfill has 50,000 tons of waste in it. So in that problem, that probably would be some important information. So I'm going to use T for the total amount and say, okay, we have 50,000 tons of that waste. Each month, it accumulates an average of 420 more tons of waste. More, of course, means we're going to be adding to that. So 420 more tons of waste. So we're going to use M there. So here would be a function rule to represent the total amount of waste after a certain amount of months. We don't want to solve it. We just want to translate it into a function rule. Now, on number two, we're not only going to write a function rule, but we're also evaluating. So evaluating means, yes, now we would solve that function rule. So in this problem, we have a kennel that charges $15 per day to board dogs. Upon arrival, each dog must have a flea bath that costs $12. So write a function rule for the total cost for n days of boarding plus a bath. So how much would a 10-day stay cost in that case? So first I'm going to write, okay, T again I'll use for the total amount. We have $15 per day, so I'm going to use N, and then adding the bath, the cost of the bath. So here is our function rule. And now we want to determine the cost after 10 days. So of course we would just plug in 10 for my variable there. And that would then give us the cost of the boarding for 10 days in this case. We should end up with $162. Okay, now the second question here says, does a 5-day stay cost half as much then as a 10-day stay? So think about, do I just need to divide $162 by 2? And that will tell me a $5 stay? Well, the problem here is the $12 flea bath. That doesn't half just because the dog stays half as long. So that kind of throws a wrench in that situation there. So here, does it cost half? The answer is no, because of the $12 flea bath. It doesn't change. So you can kind of add your own words there. I just said because we still pay for the bath, no matter whether you stay 2 days or 10 days. So that kind of throws a wrench in that. Now we have problem 3 here, which would be writing a nonlinear function rule. So again, just translating. So here we want to write a function rule for the area of a triangle whose height is 4 inches, more than twice the length of its base. So what is the area of the triangle when the length of the base is 16 inches? So this is nice because it's a kind of that geometry connection. So we have to first know that the area of a triangle is 1/2 base height. Another way to write that is base height divided by 2. Same idea. We also need to say, okay, it tells us here the height is 4 inches, so 4 plus more than twice the length of its base. So we'll put 2b there. So the height is 4 plus twice the base. So first we're going to come up with the equation. So we're going to have area. We have 1/2, of course. We still have the base. We don't know what the base is, but this is going to take the place of h in our equation. So in parentheses, I'm going to add in the 4 plus twice the base. Okay, so here's our new equation. Now, that would represent our function rule, and we want to also answer the question, what is the area of the triangle when the length of the base is 16 inches? So what we'll need to do is plug in 16 where we see b in our equation, and we would solve for the area. Now, remember, you want to use order of operations. So you're going to want to do the parenthesis, what's inside the parentheses first, then kind of work your way out from there. So we should end up with 288, and that will be inches squared because we're dealing with area, and area is measured in square units. So you should end up with that answer. So practice solving that and check to make sure that you are getting that answer there, okay? So that's really it for this lesson. We're just looking at linear or nonlinear functions kind of in a word problem format. So now your job is going to be to do your assignment, and for that you just need to look on my class website for the problems.